P6 tower. Maybe that's why I missed the one there. All right. Just this. Okay. Are you ready or no? Yes, ready or no? Another minute. Okay. Okay. So hopefully you have the average value idea, starting to get that down. What is the antiderivative of sine? Cosine or negative cosine? Negative cosine. And what about the 2? Do I adjust for that with a 2 or 1/2? So your antiderivative should be negative 1/2 cosine of 2x. That does check if I were to take a derivative, if I did it by guessing check. All right. So I get something like negative 1 over pi times cosine pi plus, oh sorry, yeah, I took out the negative, so cosine pi minus cosine 0. Negative 1 over pi is negative 1 minus 1. Did you get 2 over pi? Yes? Does that make at least a little bit of sense? If you got an answer above 1, wouldn't you know that that's just totally crazy talk? That if it's a normal sinusoid with no stretch, surely the answer can't be more than 1, yeah? Okay. Find the C guaranteed by the mean value theorem for integrals with that function. What does that mean now? The C guaranteed by the mean value theorem for integrals. Now I'm gonna, how is this different than the previous problem? Yeah, you're finding the x that makes the average value. All right, so not only do you have to find the average value, then you find the x that makes it. What are the conditions in order for that to even be possible? Continuous. So you should start by saying something like f is continuous, and that implies that there is a point, there must be a point that actually satisfies f at c equal 1 over 4 minus 3 from 3 to 4. Yeah? And as always, I do the average value, and that's fine. I can do that. 1/3 x cubed plus x squared over 2. I do my calculus thing. 64 thirds plus 16 halves minus 27 thirds plus, did I make a mistake? What?
X squared over 2. For the second part of the
Yeah, I don't know. That's a fine question. Apparently I no longer can integrate 1. Wow. I should quick check for soon on me. All right, so 4 plus 3. Thank you. I can just hear it in the halls already. He's so stupid. He can't even integrate 1. You got me. What am I gonna say? I failed. 37 over 3 plus 1. So I get 39, 40 thirds. Yeah. Now that's great, but that's just what the average value is. Now I have to say, all right, I know what the average value is. Now, what is the place on the x squared plus 1 curve where that's made? And roughed it. X c squared, right? So c squared needs to be 37 thirds. So is c plus or minus the square root of 37 thirds? Just plus. It's got to be in the interval. So only square root of 37 thirds is the x value at which the average value is. Understood? Okay. Today it's distance palooza. But first, let's warm up further. Would you go to box 1? And let's look at this. I am giving you a little graph over there of the velocity. Not because I want you to give me answers, just tell me what these mean. So, what is the integral from 0 to 3 of v? That's a lot of rate times time, but they're negative rates, so that is displacement. Okay, on the interval. This obviously wouldn't cut it on the AP test. You would have to do way more, but let's just go through the idea. It's displacement. What about the integral from 3 to 5? It's displacement, and because velocity is greater than 0, it's also the distance. Okay? Because it's always moving forward, how much you change position and how far you go, they're one and the same. What about the integral from 0 to 5 of v? That's displacement or net. All right, so we can say that when you allow v to be v, then you are allowing it to be negative in some cases, and you're saying v and displacement go hand in hand. That's true in 1, 2, and 3 dimensions. That's true in all levels of calculus. You'll do these problems later in 2-dimensional movement or rectilinear movement in the second semester, and it's still the same idea. Integrate velocity in 2 dimensions, and you still get displacement. All right. What about when you integrate? What is the absolute value of v, also known as? Nope, you're not listening to my question. What is the absolute value of v, also the same? Speed. Okay, you answered the question you thought I would ask, and not the question I actually asked. The absolute value of velocity is speed. If you integrate speed, what do you get? That's distance. Okay, you're removing the sign from the calculation. I don't care if it's forward movement. I don't care if it's backward movement, up, down, whatever. Just remove the sign and tell me how far did it go. When you see a fraction, you should think average value. Anytime you see a fraction, it's average value of whatever function is in the integral. And so, in the last class, I had a mixture of 2 answers. I said, so that's average displacement, right? No, it's average velocity. It's the average value of whatever the function is that's in the integral. It's the average velocity. Let's think about why that makes sense. Okay? Obviously, on one level, it makes sense because that's the average value function, right? Yes? Let's also think of this in a fundamental theorem-y way. What is, if I were to do this part, what's the antiderivative velocity? Position. So wouldn't you say that this is x at 3 minus x at 0 over 3 minus 0? Isn't that average velocity? Change in position over time? Yeah. So it makes sense on a whole lot of levels. How about this? This is average speed. Okay, not distance, it's the average value of what's in the integral. And what's in the integral is speed. So it's average speed, not average distance, average speed. What about this guy? Average acceleration. It's change in velocity over time. Change in velocity over time is acceleration, and because this is over an interval, it's average acceleration, not instantaneous acceleration, no derivative, right? What is this? It is position at when? Anytime or at time 3? Time 3. Okay, let's talk about this on lots of levels. Isn't this starting position? And isn't that either displacement or change in position? Doesn't it make sense then that it would give you starting position plus change in position gives you ending position? Okay? Doesn't it also make sense that if I use the fundamental theorem on V, it's x at 3 minus x at 0? So again, yeah, x at 3 will be the starting position plus the change in position over the interval. It's really just the fundamental theorem rearranged. You with me? All right, cool. Now let's talk about more movement. This is the last linear movement before we get to rectilinear movement, so that's good. Distance, part 500. Here we go. So what we just talked about, but if we don't care about direction, then we deal with what? If we don't care about direction, then what are we dealing with? Speed. And that usually relates to distance as well, okay? If we do care about direction, then we care about velocity. And that's usually displacement because it allows for positives and negatives. Cool. Now then, take a look at this here question. I give you a position function. This is linear movement along a horizontal number line, all right? So you've got this position cube function. What is the position at time 0? That's a softie. 1. Excellent job. So proud of you. At position at time 3 is 27 plus, what, 27 halves minus 18 plus 1. A little less clean, but definitely something we can do because we still remember our arithmetic skills, right? But we do, Elaine. All right, so 27, that's 9 plus 1, that's 10 plus 27 halves. What do you get? 47 halves. I agree. All right, so a classic trap question then would be they ask you A to set you up for a mistake in B. All right, so you found position at time 0, you find position at time 3, and then they say, all right, now what's the distance you traveled from time 0 to time 3? And you can imagine by far the most classic answer is to say, well, 47 halves minus 1 is 45 halves. Did that person travel 45 halves? No. Could have maybe, but only if it was distance and displacement. What did they find? That's displacement, change in position. Placement. It's just the change in position. It is not necessarily distance. People are quick to answer, just take the difference between the two, boom, that's the distance. It's not, it's the displacement. The correct way to do this, now this seems totally counterintuitive on one level, and I can see why, but how do we just say we find distance? It's the integral of speed, yeah? Didn't we say that integral distance is found by saying, I don't care about the direction, just make all movements positive and total it all up, yeah? All right. Now with the calculator, you could just type that in. In fact, feel free to just type it in the calculator so we have an answer to verify when we do this without a calculator, please. I know that's a drag to have to take the derivative of position so that we can put it the antiderivative in. I know that's crazy, but it's not like we can. No. there's actually another way to do it, but we'll do it this way, it's better. Okay, we need to take into account the absolute value, and that means then you need to take the derivative in the anti. Anybody have an answer for me? What is v, by the way? 3x squared, 3t squared, plus 3t, minus 6, but in absolute value, yeah?
Yeah.
Okay, so what, 29 or something like that? 29.5? Okay. All right, the calculator's failing us, it can't do calculus. 29.5, are you with me? Okay, now if you did get that, then let me know, but otherwise let's talk about the meat of this problem without a calculator. So, without a calculator, let's review. How do you take a derivative of absolute value? Split it using piecewise, yeah? Piecewise on flip, no flip. Well, same for integrals. It's got to be piecewise. All right, so I want to integrate or find the area under this curve. So if v is 3, t, that should be squared, shouldn't it? Oh, sorry. 3t squared plus t minus 2 if I factor out the 3 up front, sorry. You follow? And I actually want an absolute value of this stuff on it. Isn't that then 3 times t plus 2t minus 1 in the absolute value? Right? So if I were to go to graph this for the zeros, negative 2 and 1, and normally without the absolute value it would want to be a parabola, yeah? And with the absolute value it wants to be a W. What is a W? Do you agree with all those pre-calculus ideas? All right, thanks. So if we were to rewrite this integral, then I could say, therefore, this integral of the absolute value is equivalent to two different integrals. The first is from, now remember, we started at 0. So 0 to 1 of, now I don't need to write that whole big thing in there. Instead, let's just talk, is it v or opposite of v?
Opposite.
So it's the integral of opposite v from 0 to 1, and from 1 to 3, is it opposite v or normal v? I didn't do any flipping there, so it's normal v. Okay? Again, I don't need to write the function in there. It's all good. What is the antiderivative of negative v? Negative, not even that many details. What's the antiderivative velocity? Position, yeah? Isn't it position? Are you with me? Okay? And the antiderivative of negative would be the opposite. Is that? It feels like that didn't go well. Are we cool?
Yeah.
Okay. And x from 1 to 3 because that was not flipped. Now we're getting somewhere. I still am not going to put the x in yet. Isn't this then negative x at 1 plus x at 0 plus x at 3 minus x at 1 by fundamental theorem? Combine a little bit of like terms to save myself as much plugging and chugging as I can. I get x initial plus x at 3 minus 2x at time 1. I already have most of this. X initial, I think I already found, and it was 1, if I remember right. Yeah? And I think x at 3 was found, but I don't remember what it was. What it was? 47 halves. All right. What I don't have, unfortunately, is x at 1. So I will go off to the side and find x of 1. I think it's 1 plus 3 halves minus 6 plus 1. Check me on that. I'm going by memory. So that's negative 4 plus 3 halves, or negative 8 halves plus 3 halves. So negative 5 halves. So I have that. I can plug that in for x of 1. And I get maybe 1 plus 47 halves plus 10 halves. If I fight the temptation to cancel the 2's and just leave them halves, because I'm going to need them anyway. So what, 57 plus 2, 59 halves. 59 halves obviously is 29.5, which is what we got from the calculator. You follow? All right, so the idea is to find distance, it's the antiderivative of speed or absolute value, and to integrate absolute value, you got to go pieces. So cool? All right. Try this one. Now, this, depending on the lesson, if I feel like it's easy, then I don't see the point of giving more examples. Might as well just talk about the homework. Now, that said, this problem is number 3 on the homework. I don't care if you just put it in your notes because you want your notes to be complete. Fine, put it in your notes. If you do it on the homework, that's fine, but you only have to do it once. You don't have to do it in both places, all right? So whether you do this in your notes or the box, whatever you like, just do number 3, please. If you do this in your notes, then you have problems that just say in notes. How we doing? Did you get 4.5? Okay. That sounds like I made a mistake when you made a mistake. But I'm having a bad day, so I guess I'll bet on me.
I made a mistake.
Okay.
I made a mistake.
So, do you agree with the big idea of the day that the distance is the integral of the v, or the absolute value of v? Okay. To get the absolute value of v, first we need v, and we get v by taking the derivative position, yeah? So do you agree that now we have the absolute value of 2t minus 3? All right? 2t minus 3, to see what the absolute value does and where it does it, you really, if you want to work graphically, great. If you know the graph, great. If you're flying blind, if this is some graph you don't know, that's a bad case scenario. I should have probably put one in my notes. But imagine you had no idea what the graph looked like. What would you do? You need to establish where it's being flipped up and where it's not, right? So what would you do? So where, first of all, doesn't the flip parts happen when the velocity is 0? Okay, so if that's the case, if you have no idea what the graph looks like, you start by saying, all right, I set the velocity equal to 0 because that's the flip points. Then you need to establish where it's positive and negative. How would you do that? Again, given that you didn't know the graph. Yeah, you'd have to do a sign test to see where it's positive and negative, and therefore flipping or not flipping. Then you'd have to set your integrals. Now, I should have probably done one that was graph unfamiliar, but you guys know so many darn graphs. It's hard. But anyway, do you, so not Brendan, but many people, did you say 0 to 3/2 is opposite v and 3/2 to 3 is normal v? Okay. Did you just call the antiderivative position and hopefully get eventually something like, with combined like terms, x initial plus x at 3 is minus 2x, or minus 2x at 3/2? And then last but not least, I guess, did you evaluate x at 3/2 correctly, which was negative 1/4, I think. So we're good? And obviously, it's fine if you made a mistake, but do you see where your mistake was? All right. Then let's talk one more idea. Now, this is a bit of a hodgepodge. Distance is, without a calculator, is the biggest idea, but this is a small little fun dessert problem kind of thing thrown in there. Average value with motion. So, on Mars, acceleration due to gravity is negative 3.8 meters per second per second. Matt Damon, you ever seen The Martian? Good movie, such a good movie. We should watch that in class, am I right?
Yeah.
I should have a clip right now. I don't. Okay, so anyway, throws a ball horizontally at a rate of 20 meters per second from a release point of 2 meters. That's what we should do Wednesdays. Just watch The Martian. If you want to take a nap, seniors, you can.
Yes.
Oh, that's good. Yeah, I'll go get it. Okay, so I'll try and get that at the library and we'll make that happen. All right. So, at any rate, so they eventually asked for the average height of the ball while it's in the air. Okay, so how do you reckon you're going to just get us started? How will you find average height? Yeah, the average value idea. So let's go with the, I mean, when you hear average now, you should have two levels going on in your mind. Are they talking average rates of change, which is what you've been doing forever, secant sloping kind of thing, or average value, in which case now you're talking this integral. Do you agree that average height is more like average value of height, so it's this integrally idea, okay? You down?
Yeah.
Now to make all that happen, what am I going to need? I need the equation for height, which I do not have, and I will not just regurgitate from physics memorization. I'm going to develop it. And what else will I need? The bounds. Yeah. Now, one of those bounds is pretty obvious. What is one of them? 0 when it starts being in there. But the one we don't know is when it hits the ground, stops being in there. So we're going to have to go find that too. What should we do first? Integrate. So let's start with acceleration due to gravity is negative 3.8. How do we find by calculus the velocity? The antiderivative of that. So that is negative 3.8t plus the first constant. So, tell me, it says the ball is thrown at 20 meters per second. So at time 0, velocity is 20? Okay, what's the key word there? Horizontally, all right. The ball is thrown horizontally. Now, these are vertical equations we're working in. This is the vertical velocity. So at time 0, what's the vertical velocity? 0, okay? So that implies C1 is 0. All the initial movement was in a horizontal fashion. So the velocity is just negative 3.8 t. Now the height. Again, showing the calculus, I need to integrate. Oops, with respect to time. So what is the antiderivative of negative 3.8 t with respect to time? Negative 3.8 t over 2, so negative 1.9 t squared plus a new constant, yeah? You have an initial height condition. 2 at 0, so that's cool. The height equation is negative 1.9 t squared plus 2. Are we cool? All right, now what? Solve for t when the height is 0, and the positive version would be the square root of 2 over 1.9. Yay? Should we leave it that, or do you want to call it? Do you want to call it something? You want to write that around, or just leave it? Feels like it's wrong to kill.
It's a loss. So
Worse. Sorry. Guess it's not meant to die. If somebody's allergic to sensation, probably leave.
Where is that? That's cute. It's a horsey.
What was it doing to you? Nothing. All right. Doing a living thing that's not right. All right. Okay, so that's the time we're cool. So now let's go to find our average height. So what are we gonna do? 1 over square root of 2 over 1.9 minus 0 from 0 to 2 over 1.9 of, be careful you copy the right function, acceleration, velocity, and height are all there. We're going to use negative 1.9 t squared plus 2. All right. If you throw that into your calculator, the highest point is 2 meters, and it feels like the average height then should be less than 2 meters. So if we get something above 2, we definitely have an error. I don't know if it would be easier to calculate that and just store it as A or something, so you don't really want that. Answer it? 1.3. Okay. Makes sense. A little less than 2. It's get a little spend a little more time at the upper level. Once it starts falling, it'll start falling sharper. So that's fine. That is that. Are we good with? I think that's the end of the notes. Is that right?
Yes.
Okay. So we're good there. Shall we look at the test or go over questions on 89?
Test. Test.
All right. Let's look at the test.
It's not
Oh, thanks. I love you too.
Yeah, that's what I told you.
Okay, and Marina. Okay. Okay. Feel free to pull the desk out if you like. Okay, so, first of all, the scales or whatnot, or how I scaled it, the first page, let me remind myself, sorry. The first page was 20 to 24 was an A, and so 20 was a 90, 21 was a 92.5, 22 was a 95, nope, sorry, 21 is a 93.3 repeating, 22 is a 96.7, and 24 is 100. B, I went down to 16 there, 16, 17, 18, 19, so 16 was an 80%, 83.3, 86.7 for 17, and 19 was, nope, these 0.5s, 82.5, sorry, so 17 was an 82.5, 18 was an 85, and 19 was an 87.5. And then C, I went down to 12 on, 15, again by 2.5s. Okay, so at any rate, first page was pretty good. Let's talk about the common mistakes, shall we? Both versions are the same, just the rearrangement of order in some cases and such. All right, so for this, 1 point was for, did you take the log of both sides? You should have taken the log of both sides, yes? 1 point was for taking the derivative of both sides. That's 1 over k prime equals, and then f over x plus f prime log of x. One point was for finding the derivative, and 1 point was for evaluating. The answer should have been 32. Depending on your version, what might be next might be different, but you'll have to just look around. What the heck? Thought I had at least a couple problems before this. Oh, what the heck? Okay, so do you have a problem like this somewhere, yeah? Any question on number 2? Did it freak you out to choose none of these? I like that. You say, oh, am I doing something wrong? If you have confidence, then you're good. Number 3, I was actually really happy with how number 3 went. For the most part, people did the definition of the derivative and didn't try some crazy shortcut. So if you started with something like this, then you were on the right track. Then you had to go each one specific and evaluate, showing the derivatives are different. I was very happy there. Great job. Go to the force and work problems. This blew my mind. So I had so many conceptual errors on this last year, force and work, that I really have tried to improve. I just wrote copious notes to myself. You got to do this better and that better. So all the things I tried to do, differentiating between depth and distance and all that stuff, total success. What I didn't expect that I would have to teach is how to find the slope of a line. So yeah, it's rough. I guess I'll have to build that into my lesson next year. But what's the slope of this line? It's up 4 over 6? No. Is it up 3 over 4? No. It's up 4 over 3. I can't, that was the most missed part of this problem, is that people didn't find the slope correctly. That is amazing. Overall, though, I was very happy. That went well. Great job there. Go to the back. I'm going to have to rearrange this a little bit, I bet. What the heck? Sorry. All right. So this is a great motion example. It's a really well written, gets it whether you know your stuff or not problem. I love it. Many people missed points on the explanation because they were missing the units. When they say explain, using appropriate units, explain the meaning. Okay, I feel like people think, well, if I just put units on my numerical answer, I'm good. No, you're not. It says in the explanation there have to be units. In the explanation, not the numerical answer only. In the explanation. So if you're thinking, if you at the end say, oh, this is feet, I'm good. No, you're not good. It must be in the explanation. Okay, it has to be something like the integral represents, this is the distance in feet traveled from time equals 30 seconds. I can't tell you how many people put meters. At least 7 people put meters. Read the problem. 30 seconds to time equals 60 seconds. Then the calculation, some people forgot absolute value. Obviously, you need to be careful there. The second one was a bit of a gotcha. First of all, do you agree it never reads approximate? It says exact. And so how are you supposed to find this exactly when you don't have the equation? Fundamental theorem. What's the antiderivative of acceleration? Velocity. Now this is one of the few times where I actually rearranged the order. I looked at that sentence and interpret that. So it's accumulating change under acceleration area. I got myself all confused. So I just went on to the calculation, and then I saw that, and I said, oh yeah. Okay, what is this meaning? I don't know, but it means the same as this. What does this mean? It's the change in velocity. That's it. It's the change in velocity over the time interval. Okay, that integral represents accumulation of change. So if you were to get, what is it, something like -6 or something, yeah? Is that right? It's positive 6? Yeah. Okay, sorry. 6 feet. Now, those, do I use acceleration units or velocity units? Velocity, it's feet per second for 2 reasons. Either because here it's feet per second, or here it's feet per second, but times dt is seconds. Either way, you're getting feet per second. It's change. The integral is the change in velocity. Now, once again, it says with units. So change in velocity, units in feet per second from time equals 0 seconds to time equal 30 seconds. And there it helped if you thought about it in a fundamental theorem-y kind of way. Doggone this thing, it's making me crazy. Please do jump in with question. All right, C was fine, it was IVT, most people did IVT well. D was not meant to be IVT, it was MVT or relay. I love that many people saw this. I had a lot of people get too literal and they said, hey, they said 0 to 60, and 0 to 60, that's not an average rate of change of 0, so it's a no. It's 0 to 60 or any points in between, not just 0 to 60 only. Is there any case where the average change was 0? Yeah, if you look there, the average change over that interval is 0. So there must have been a time in 0 to 25 where the instantaneous change in velocity or acceleration was 0. And E was great. Speed is increasing or decreasing when V and A. So I had a few people. I took off for something. What was it? I had a few people have me do more. What was V? It was like negative. Sorry, I'm all over the place. V is negative 14, and acceleration is. That's what people said. Okay. I had people say speed is decreasing because velocity is negative and acceleration is positive. Do they get credit? It's so subtle, but they don't. Why? Yeah, I mean, imagine if somebody read your directions and used what you said literally. What if somebody reads the next problem and A was positive and V was negative? Would they, or sorry, the other way around, would they conclude properly? So, no, you have to say opposite signs. You can't make me do that before you. Hey, can I get these tests from you? We'll finish going over the page 2 tomorrow. Have a lovely day. 89, is there any reason why you came from an 89 today? Other than we not having any question time for it? I guess you can keep it till tomorrow. Tomorrow's question for you.